Introducing Dr. Harold E. Edgerton of the Massachusetts Institute of Technology. His stroboscope light, my friends, is really something. It's used to unscramble engineering problems, and it's put the super in super-speed photography. The principle of this high-class gadget is a light that flashes on and off at variable speeds. Through this invention, you can examine machinery in motion. Here, a common electric fan is used in a simple demonstration that even I can understand. Or can I? Anyway, when you direct this light on a fan and synchronize the light flashes to the revolutions of the fan, the blades appear to be stationary. To make sure they aren't, it's better to turn an ordinary light on the fan than to stick a finger into it. Defects evident only while a machine is in motion are thus easily discovered. In case you're still skeptical, we'll drop an egg. Fresh, I hope. Yes? No. That egg smashed in the blink of an eye, but let's drop another and see what really happens. It bounces from blade to blade before it breaks. Interesting. Note the narrow blades on this fan. It's an old-fashioned air storer upper that gives off with a minimum of breeze and a maximum of noise. And so, using smoke to point up the action, our prof shows us what these fan blades actually do to the air. Chopping the ozone, the narrow blades send off small whirlpools of air which quickly break up. In seeking a fan that would be more silent and efficient, designers wanted a blade that created less air disturbance. Wider blades, through patient experiments made possible by the stroboscope and other related equipment, was the solution. These blades created a smoother flow of larger whirlpools, and the vortices were of longer duration. This meant less atmospheric disturbance, hence less noise. In fact, electric fans in offices are now so silent they no longer disturb sleeping employees, period. Still photographers are very busy these days snapping pictures of fast-moving objects and whatnot. A fair degree of clarity is attained with the aid of the modern flash bulb attached to the camera. We'll see the results of this later. Edgerton uses the same camera. When it's hooked up to his things and stuff, however, he makes the average action picture look like a broken-down tintype. The high-speed light does it. Each flash of that light lasts 1/30,000th of a second, which is faster than a goose in a high wind. So, we take the picture. Here's that first picture made with the usual flash bulb. Note how the shoe and ball are blurred. And here's the photo by Edgerton, clear as a California morning. Well, some California morning. While normally film runs through the average movie camera at 90 feet a minute, Edgerton's flicker box can handle 125 feet a second. The camera has no shutter. Connected with it is the unit containing the Thyrotron amplifier and, boy, am I getting over my head. Anyway, flashing on and off up to 2,000 times a second, this light makes 2,000 exposures a second on the film in the camera as it speeds past the lens. And so it is now possible to get ultra-slow motion pictures. First, Charlie Lacey will hit the ball through this telephone book. Maybe. Here it comes. Wow, look at that. Charlie has ruined a lot of good names, and good phone numbers, too. Woo-woo! I always thought that my cat, in lapping her milk, curled her tongue up. But now it's revealed that she curls her tongue down. See? In other words, she brings the milk up on the underside of her tongue. Now, see how smart you get when you go to the movie? Here's something interesting. Now, break it up, fellas. I'm referring to the soap bubble. Anyway, by photographing this action at the terrific speed of 1,500 pictures a second, we find that the bubble does not break when the pencil punctures it. In fact, the pencil penetrates almost to the other wall of the bubble, and now it breaks. And now it breaks. And now it breaks. Thank you. In normal speed movies, a bullet shot from the muzzle of a high-powered air gun is invisible. Now Edgerton really photographs a bullet in flight. Watch it come in from the left. Here, fascinating patterns of movement. And when you recall that all the action of this bulb smashing actually took place in the fraction of a second, you realize that here is speed in movie photography, indeed. To the naked eye, milk dripping on an inverted dish is, well, it's milk dripping on an inverted dish. However, what actually happens is this. A big drop breaks loose. Then it's followed by a tiny drop. First a large one like this. Then a little one. The little drop always follows the big one. Watch. Well, almost always. As the drop hits the thin layer of milk, it forms a crown. Pretty? Another one. Well, so much for the fancy diadems. We'll now slow down the action of smashing a cup of milk and see what happens. Zoom! Up goes a long spout of cow stuff in interesting gyration. Yes, quite. When you drop a golf ball into a pail of milk, and I often wonder why you would, a bubble will start to form, but before it's completed, a stream of milk spouts way up into the stratosphere. A column of milk now begins to disintegrate. It starts to break up. Our milkman found these experiments very interesting at 13 cents a quart. The beating wings of a hummingbird are so fast they appear only as a blur. But here the actual action of the wings is captured by stroboscopic movies. Of course, now that we want him to fly, he settles down for a drink. Temperamental, these movie stars. His tongue, incidentally, is tubular, like a little hose. Well, he's off. By the way, through these movies, it was possible to measure the veritable speed of this wing action. It was found that a hummingbird's wings beat as high as 70 times a second. In conclusion, we go to the dentist for our final super-speed pictures. Most of you have heard, and perhaps have even felt, that cute little drill. Oh, but have you ever seen it in use? In ultra-slow motion? No? Well... Ooh. Wow, there it goes. Gosh, what's he drilling for? Oil? This looks like a scene from Boomtown. Okay, mister, it'll all be over in a minute. What fun. And so it is with this happy thought that we reluctantly bid farewell to Stroboscope and sail into the setting sun. Adios.